See, according to theorem 4, if mth term of an AP is n, means it is given that Tm equals to n, and mth term is n. So Tm equals to, oh I have written I think both the side n and n. Nth term is m. So here nth term is m. We have to prove pth term equals to n plus m minus p. Okay, these two things are given, that mth term of an AP is n and nth term of an AP is m. We have to prove that pth term of the AP will be n plus m minus p. So in this theorem what we will do, at first with the help of these two given thing we will try to find two equation. So see, since Tm equals to n, we can write a plus m minus 1 into d equals to n. Let this is equation 1. And since Tn equals to m, we can write a plus n minus 1 into d equals to m. This is equation 2. Now we will subtract equation 1 from 2. So from equation 1 and 2, a plus m minus 1 into d equals to n, a plus n minus 1 into d equals to m. Subtract it, this get cancelled out. M minus 1 into d minus n minus 1 into d equals to n minus m. Take d common, m minus 1 minus n plus 1 equals to n minus m. This 1 cancel. D equals to n minus m by m minus 1, you will get minus 1. Now after finding the value of d, now we will find a with the help of d. So see, since a plus n minus 1 into d equals to m, so a plus n minus 1 into minus 1 equals to m. So it will be a minus n plus 1 equals to m. So we will get a equals to m plus n minus 1. Now after finding a, we have to find pth term. So I hope you have written this all. I am erasing this. See, Tp equals to a plus p minus 1 into d. So here we get the value of a as m plus n minus 1 plus p minus 1 into minus 1. It will be m plus n minus 1 minus p plus 1. This 1 and 1 get cancelled out. So what we will get? We will get n plus m minus p. I think this only we need to prove. So if the mth term of the AP is n and nth term of the AP is m, we can write that pth term will be n plus m minus p. I hope this fourth theorem is also clear to you. Now let us discuss the fifth theorem. Okay, see, theorem 5 is, if m times the mth term of an AP is equal to n times the nth term. Okay, m times the mth term is equal to n times the nth term. This is given. We have to prove that m plus nth term of the AP is 0. Okay, so see here, since m into mth term equals to n into nth term, we can write m into a plus m minus 1 into d equals to n into a plus n minus 1 into d. So it will be m a plus m into m minus 1 into d equals to na plus n into n minus 1 into d. Now what we will do, we will take each and everything in one side. So see, ma plus m square minus m d minus na minus n square minus nd equals to 0. Now when we take a common from this, we will get m minus n plus m square minus m minus n square plus n d equals to 0. Now this a plus m minus n, see here m square minus m, when we take d common, here it will be minus n square plus n. Okay. Now from this m square and minus n square, this is in the form a square minus b square, so we can write m plus n into m minus n, and here from this we will take minus common, so m minus n into d equals to 0. Now see, a into m minus n plus, from these two we can take m minus n common, so it will remain with m plus n minus 1 into d equals to 0. Now from these two we can take m minus n common, so a plus m plus n minus 1 into d equals to 0. Now we can send this side, so a plus m plus n minus 1 into d equals to 0 by m minus n. So a plus m plus n minus 1 into d equals to 0. Now this a plus m plus n minus 1 into d is what? This is m plus nth term. Okay. So whenever the m times mth term is equals to n times nth term, we can say that m plus nth term equals to 0. I hope these two theorems are clear to you. Now let us discuss the next theorem. Thank you.